Welcome, welcome. Here we go. Solar graph. Oops, sorry. Yes. You do this on a second search, sure. Okay, so what did you get when you plugged in a zero? What's 5 cosine 0? 5? Was it 5? It better be, because if I remember my unit circle, cosine over there at 0 was 1, because it was the x, you remember? Okay. And then 1 times 5 is 5. Put a dot on 5 comma 0 degrees. New circle? New circle, yes. All right, and what'd you get when you plugged in 30? 1 decimal place, thank you. 4.3-ish. How about 60? That was straight up 2.5, right? And then 90 was zippy. Yeah, where'd they come from? Your calculator. Okay, now plot these 4 dots. 30 degrees, I go out 4.3-ish. 60, I go out 2.5. And then I got a dot at 0 because it didn't have any radius. All right, what do you see right now? I know you're going to say trapezoid, but it's half a circle. So we're not done. Try 3 more. Put in 120, 150, and 180. On your quiz, I'm going to have you do this 1 time just to prove you can do it. Plot dots and play connect the dots. Five cos 120. That sounds like a negative if I know what cosine is in second quadrant. Negative 2.5. And I'm starting to see a pattern. Yeah. Starting to see a pattern. What's 150? Negative 4.3. And then without the calculator, look at the pattern. We went 5, 4, 2, 0, and then 2, 4, what? Yep. Use your calculator, but anyway. So where is 120, but 2.5 backwards? It's down here, right? And 150, go backwards 4.3. And then magically, this is how you know you're done. This guy. If I go to 180, where's negative 5? Was the opposite side. I've already got a dot there. That's how you know you're done. Now connect these with a smooth curve. And what was r equals 5 cosine theta, a circle? Who knew? Nobody. But now you do. Okay. So bookmark this problem. I'm giving you one of these on the quiz where you actually have to plot some dots and draw me the shape. Okay. Now, couldn't we have used the calculator and do this? Yes, we could, but you don't know how yet. Let's go calculator mode. And yours will say pole. One says polar. Oops. Change it to polar. Now when you press y equals, mine's going to be blown. What's it say now? Doesn't say y equals anymore. So I'm going to type in 5 cosine theta. Where's theta? You remember that X button? Who else is on there? Theta, she's on there. The X button, you're like a junior, senior in high school, you don't know where the X button is on the calculator. It's in red here, I just pushed it. Okay, now, when we press graph, if I'm in the right mode, I think they want me in radians, but we'll see. Yeah. So for some reason, they want me in radians, but what should you see? A football, circle. Radians. Okay, does anyone know why it doesn't look like a circle? Radians.
The X.
Yeah, you see how the X's are spread further apart than, so what could you, if this annoys you, and I know it does, go to Zoom. Zoom 5 will make that disappear. Okay, so we're gonna play discovery learning now. Okay. All right, discovery learning. Can anyone tell me which quadrant is it on, or which axis is it on? And if it's cosine, does that make sense? Remember how cosine's been X all along this year? So if I change this to sine, what are you expecting? Same picture, but, so we're playing discovery learning. Change that to sine. Finance. Cabri Jr. What the heck's that? Yeah. Whoa. Oh. And sure enough, there it is, mind blown. Circle on the y-axis. Okay. So those are circles. All right, let me give you the laundry list of these, but play around with it a little bit.
Why does it do this when I do 10? It gives you wings.
Gives you wings. Okay. So the first thing you'll see are the circles. Let's try it again. All right. Highlight this. Those are the forms for circles. Which one did we already do? We did R equals 5 cosine and 5. We did both of them. Okay. However, there's an extra one, which I don't see. Add this. It's this one. R equals a number. Okay, so give me a number and a number. 5. Okay, so what if I gave you R equals 5? Did it tell you anything about the angle? No, because there wasn't a theta in it. But what did it say that R had to be every single time? 5. So R equals 5 is basically this guy. Go out 5 and circle them up. Didn't say anything about theta, but it said R had to equal 5. Okay, so to recap, circles, if it's cosine, it's going to be on the x-axis. Sine is going to be on the y, and if there ain't no theta, it's got 0, 0 as its center. Those are your circles. Circles, we know. But how about these other shapes? Here we go. I guess I'll give you this. Okay. Add this one, also not pictured. theta equals. So example. And what if I gave you this one? And said sketch it. Does it say what R has to equal? No, but it says that theta had better be 30 degrees every time. Okay. So theta equals is a line, wrong, even in polars. Okay. Go mountain line there. Okay. All right. We already did circles, so you already have those on your sheet. But what's the next one? Any French scholars out there? You're supposed to say we. We. Yeah. How do you pronounce that? That's close. That's close. Nobody taking French in. Oh goodness. The Washington football team had a wide receiver. His name was this. Nobody remembers him, I guess. Garcon. That's beautiful. Beautiful. Oui. Okay. So this is a limaçon. Got that? Okay. And wonder what shape it is. Oh, I already gave you the handout. So take a look. I was going to do discovery learning. I still feel like doing that. All right. You do have that here. It's right under circles, right? Yep. The limaçons. Garcon won't be on there. He wasn't bad. Okay, but yeah, let's go to the calculator and type in what we think will be a limaçon. It's on your sheet, right under circle. Yeah. All right, so what if we go with 4 plus 4 cosine theta? Okay. Naturally, the plus didn't show up. Hang on. Okay. Describe this. Yeah, in fact, this one does have a special name. It's a cardioid. Cardioid. And what is that in reference to? What you said it just looks like a heart. So you don't have to memorize cardioid, but this is what happens when it's 4 plus 4 cosine. Now, did anybody think it looked like something else?
Yes. Yes.
I had that. Upbeat, thank you. Okay. Keep it clean. All right. How are you gonna memorize that is gonna give you a beam? Look at the name again. What word do you see in there? In the proper color and everything. Okay, see, that's gonna be the beam. You like? Okay, because on your quiz, I'm putting 5 of them, and you got to match them up with the picture and the equation. Okay, so that was when A equaled B. It was a whatever you said, not you. Okay, but let's change them around. What happens when we make A the baby and B the biggie? So let's change that. Big. Afraid to ask here. All right. Yeah, let's go here. Let's make that 5 plus 4. All right. Did that change anything? What's the only difference? Please stay with. It didn't go to 0, 0. That's the only difference. Now change the 4 and the 5. And This is the limousin with a loop. Can't see it too well, but that's the limousin with the loop. They're all on here. Okay. Boom, boom, boom. The very first picture is the limousin with the loop. And when did that happen? The fire. When B was the big dog. When A was the big dog, it didn't go to 0, 0. Okay, so those are limousins. All right, next up, in your honor. Guess not. All right. All right. Okay, the next one, me in the book, I had an argument. I call it a flower. Book calls it a rose. I'll let you decide after we graph it, but copy this down. You should know either word. It's not a hyacinth, but we'll go with flower. Yeah. The key is the number in front of theta. If that number is odd, hey now, that's how many petals you're gonna have on your flower. If it's even, well, double it. Okay, so in the calculator, we're gonna go try this one. Everybody got this? Is that playing? Okay. Assess this with me. How many petals should it have?
3.
Which number?
3.
3. Because that's odd, that's how many petals you got. So let's type that in, 5 sine 3 theta. I love discovery learning. Now I forgot what I had in there. 5 cosine or sine. What did I have? Sine? 3 theta. Okay. Now, are you with me or again me? That ain't a rose. Okay. I bring that to my wife. I got you a rose. She'd be like, thanks for the daisy. And put it out in my face, I think. But okay. Now let's assess. What if you change the 3 to a 4? How many petals are you expecting that?
8.
Doublets if it's even. So if I change that to a 4, I should be seeing 8. Okay. Count them up. Why don't you play with it a little bit? I knew this would happen. Exactly. I know where you're going.
That's not working.
What'd you do?
Something.
What'd you type in? I should ask. R equals 5 sine 4 theta. And are you in radians?
Now.
Good answer. Give me some to try for the good of the class.
It's still a line though. Otherwise it's long.
Do Zoom 5 or Zoom 6. 20?
20 is ugly.
Yeah, it does have some flaws. 11 theta. Hmm. 11, that's kind of disappointing.
That's only 10. That's only 10.
What do you want? Just plain old 8 or 18? 8, because that's your number. You didn't do that on purpose. Okay, and there's 8. I'll bet there are 16 of them. I do. All right. Anyway, anybody find some real wacky ones? How about like 44 or something? Or 85? I'm going with 85. Yep, worthless.
I did 45.
That's weird. How about 33? I'll try that. I don't know. Anyway, yeah, because his jersey number is number 8. Does it work or? We don't have a 42, do we? Yeah, I had a guy that played for me at Mount Vernon, and his name was Jarvis Robinson. So naturally, I gave him 42, as I said, J. Robinson. Pretty cool. Clever, clever. All right, so those are your flowers or roses. Expect to see both words. Okay. All right, what's left after the flower? Oh, the lemmer, the lemniscate. Okay. Lemniscate or lemniscate, whatever you want to call it. Yeah, but there's a word in there. I wish. Not spelled correctly, but any skaters out there besides our rugged D man over here? Because I doubt you did any of these. All right, figure skating. What's their main shape? Figure 8. So this sucker, no lie, looks like a figure 8. All right. Well, you don't trust me. Let's plug it in. How about we go R squared equals, give me a number. 81 it is. Sine 2 theta. Uh-oh, I don't have an R squared button. Yeah, how do I make this fit in the calculator? How do I get rid of square? Boom. So right now, type in square root of 81 sine double theta. Discovery learning. Now I forgot what it was. Square root 80 wonderful sine 2 theta.
Yeah.
Right?
It's double theta.
Double theta, as I like to say. Okay, and there it is, a figure 8. If you change it, yeah, I don't know, she must have hippity hopped over here. Okay. Not that I've seen one in my life, but I think they get graded on whether they can go over the same line over and over, which I couldn't. You do hockey stop, it's kind of fun. Spray the most snow on the goal. All right, and if you change this to cosine, no surprise, it'll go on to which axis? The x-axis. Okay, so anything left? Oh, the lemmer's at the bottom of your page there, the lemniscate. All right, I do believe that is it. Oh, that's right. You know that. Is it on there? Okay. My personal favorite, the spiral of Archimedes.
Disrespect, man.
Yeah. So I know you know what a spiral looks like, but
Archimedes was that Greek dude.
yeah.
He calculated pi or one.
So what if we try? I know I'll pick a number here. How about 0.2 theta plus 0.3? And I am gonna have to change something in my window, but let me type it in. And what makes this distinctive? It's the only one that doesn't have a what in it. No, the equation. It doesn't have sine or cosine. So on the quiz, when you have to pick out which one is the, lemniscate and which one is the, spiral, okay, that's what you're gonna have to do. All right. Let's see. Okay, everybody take a quick look here, especially Landon. Ready? You will do your homework. You will do your. Okay. Yeah, you too. You will do your makeup. Okay, so that there's the spiral of Archimedes. Okay, so for homework, try one of them where you got to plot 5 dots and connect it, just so you've had to practice. The rest of them, I'll let you plug in the calculator and copy them onto wherever that page was that I gave you. Okay, but for the dot plotting, put them all on one graph so you don't waste like 12 graphs to do 12 different dots. Okay, but anyway, welcome to Polars. Welcome to. Oh, yeah. See you later.